This is computer science paper 2. I don't know what the difference is. I mean, okay, the last one was called, I can't remember what it was called. This one's called written assessment, so it may involve more written algorithms. I don't know. Right. Um, let's fill in our name and everything. Okay. Where's the... Come on, pencil. There we go. Candidate M2, as always. Okay. Are we ready? I think I won't need the pen for this because it'll probably be typing, so I'll put the pen away. Okay, let's begin then. 1.5 hours. Probably, oh yeah, no calculator, okay. All right, let's start. Start. State the decimal representation of the binary number. Okay, so that's 1, 2, 4, 8, 16. Can't. 32, 64, 128. So it's 128 plus 16 plus 4, so it's 148. Okay. State the hexadecimal representation of the binary number. Well, it's the same number. Okay, so take 148 divided by 16 is 9. What's 9 16s? 144. So 94? Is that right? So it's 9 times 16 plus 4. 10 times 16 is 160. Take away 16, 144 plus 4, 8. Okay. State the hexadecimal representation of the decimal number 143. All right, start using text box here. 143. What did we say before? So it's 143 divided by 16 equals 8. Remainder 15. Is that right? Yep. So 15. Hello, MC2M. 15 is, what is it? It's Wait. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Of course it's F. That's the final one before. Yeah, okay. So answer is 8F. State the binary representation of the hexadecimal. Ice cream and computer science, the best combo. I'm finally finding out what GCSE computer science is about. Actually, I'm impressed. It's higher level than I thought it would be, considering this is what students take when they're, I don't know, 14, 15? No, 15 or 16? I just thought it would be lower level, but they are actually covering proper algorithm stuff and programming and pseudocode and all that. Which I definitely didn't do as a kid, but we didn't have this course as a kid. State the binary representation of the hexadecimal number BE. Okay, so B is 11. So B. So it's 11. Okay, let's convert it to decimal because I can't. Easier for me to think. So 11 times 16. Plus E is 14. 14 equals 176 plus 14. Is that right? Yep. Equals 190. Equals 100, so then we have to divide it into two powers of 2's, so 128. What have we got left over? 62. So 62, so we've got 32. And then we got left over 30, so say 16. We've got 14 left over, so 8. Is this right? Yeah, 6. So we've got 4. It's 2. Okay, so how do we? So that's going to be 1. No 64s. 132, 116, 18, 14, 12. No 1s. Okay, there's probably an easier way of converting hexadecimal to binary directly. I don't know. I've never bothered to give 2 reasons why hexadecimal is often used instead of binary in computer science. Smaller length of the strings. Too tight, I guess, is one. What other reason? Why do we use hexadecimal? I'd have thought that's the main reason, smaller length strings, because there's nothing stopping you from using binary, right? It just has lots of zeros and ones. What other reason? Makes better use of, I don't know, ASCII characters. I mean, it's not like it makes arithmetic easier or something. Because it doesn't. Well, it does for humans, maybe. I don't know. I'm not sure if I know the answer to this. Makes better use of ASCII characters and key. Just say that. I don't know. feel like smaller length strings is the one and only reason, really. I mean, everything else can be done the same with binary. Whatever. Add together the following 3 binary numbers and give your answer in binary. Okay. 3 binary numbers. All right, so how do we... All right, it's got 1 plus 1 is 0, carry the 1. Every time I type is gonna... All right. Then there's a 1 there. And then we got 0. Carry the 1. So 1 plus 1 is 0. So we've got 1, carry the 1. 1, carry the 1. 0, carry the 1. 1, carry the 1. State the result in binary of performing a binary shift 2 places to the left on the binary value 0, 0, 1, 1, 1, 0, 0, 1. Left, that means multiplying by 2 and by 2, right? But we don't have enough. Oh, they have given us enough, okay. So it's just going to be 1, 1, 1, 0, 0, 1, and then put 2 zeros at the end. What is the largest decimal number that can be represented using using 6 bits? So it would be 2 to the 6 minus 1. So 63. Yeah. How many bits are there in 5 kilobytes? Okay. So it's going to be 5 times 1024 bytes equals 5 times 8 times 1024 bits. Okay. All right, so 5, what's the easiest way to calculate this? Let's say 5 times 8 is 40, so we want to do 40 times 1024. So that's, well, let's just write this out so I don't have to, like that. So we got 4, 0, 8, and then we want to multiply 4 by 4, so 960, 40960. Okay. Explain how a sound wave is converted so that it can be stored in a computer. The amplitude, so you want to amplitude of the wave is sampled at intervals I mean, the answer is kind of in the description of the next question. Each amplitude value is stored using a fixed number of bits to specify the precision. Amplitude. Then we store the sequence of bits in the computer. I mean, they're talking about digital, right? I don't know where the 3 marks come from. A student has recorded a 30-second digital soundtrack using a sample rate of 44,000 Hertz. 8 bits have been used to store each sample taken. Okay. So it's 30 seconds, 44,000 Hertz frequency, so 44,000 times per second. So what is the term you use? I don't know, instances equals 30 seconds times 44,000 samples per second. Or let's say number of samples. Number of samples equals 30. Okay. Equals that. So each of those uses 8 bits. 1 byte. Each of those uses 1 byte. So the number of bytes, size equals 1320,000 bytes, which equals about 1020 kilobytes. Okay. Shade 1 lozenge to show which statement best describes data compression. The process of encoding information to try and use fewer bits than the original. Give 2 reasons why data compression is often used. Reduce storage space. Reduce time to transfer data from one location to another. That's the two reasons, right? Time and space. You could talk about cryptographic signatures as well. No, but that's not what they're talking about. Run length encoding is one method of compressing data. State the feature of data that allows it to be compressed effectively using run length encoding. Oh, I forgot what run length encoding is. Run length encoding. I remember the term. State the feature of data that allows it to be compressed effectively using run length encoding. Describe how RLE works. Oh no. Can we get any clues from later on? Alright, now let's try and run encoding. I only remember Huffman coding. I only vaguely remember Huffman coding. Run length encoding. I mean, at the end of the day, you always want to see what sequences come up often and encode those with the smaller. Well, that's basically what Huffman does. Well, that's what all compressing does, but run length encoding. Alright, I don't know. Let's just put something for this one at least. Common, let's say, repeated use of I disconnected again. I've been having problems with Twitch lately. I'll just carry on. What was the timer? Repeated appearance of certain sequences of characters equals redundancy. No, I think they're getting at something more specific. Okay, I don't know. Shade 3 lozenges to show which of the following are essential components of the von Neumann architecture. Oh man. Do they really do this stuff at GCSE? Okay. Fed bus, probably. Memory. You can't not have memory. Either BIOS or control unit. What is control unit? It probably has different names that I'm familiar with. I'm gonna go with BIOS. Main memory is any form of memory that is directly accessible by the CPU except for cache and registers. Explain how main memory is used. It's just used whenever you need memory. Okay. Main memory is used for short-term. So, I mean, use it for short-term and long-term, but main memory is used for short-term storage when running programs and context switching. Main memory is also used for long-term storage to store data, records, documents, etc. Important. CPU. Some registers. I mean those two, right? What else do you want? You got short-term and you got long-term memory. I mean, I wanted to talk about cache, but they've mentioned cache and they're not calling that, they're not regarding that as main memory, so can't really do that. Whatever, move on. Might be losing a few marks here. The cost and physical size of RAM and secondary storage are normally different. Describe 2 other differences between RAM and secondary storage. RAM is faster to read, write to. I mean, aren't these basically the 2 reasons? The cost and the speed of access? Well, oh, I assume RAM is not kept when you turn the machine off, is it? RAM memory is cleared when the machine is off, I think. i.e. only for temporary use. Operating system manages the memory of a computer. State 2 other things that are managed by the operating system. I don't know. Security and access privileges. Input and output peripherals. Oh, they do Huffman coding. Oh wow. I might actually remember this. Use the Huffman tree Figure 1 to state the Huffman encoding for the string most. I see. So M is 1, 0, what are these numbers in brackets? SP, what's the... SP doesn't even appear in the text. Oh no, it's not. string shown below. Yeah, this is the string. Oh, SP represents a space character. Okay, fine. So it's telling you how frequent these. And the more frequent a letter, for example, S is quite frequent, the smaller string you will give it. So S would be 0, 1, 0. Okay, got it. So M is 1, 0, 1, 1, 0, 1, 1, 1. 1, 0, 1, 1, 1. Seems a bit long. No, that's about right. 1, 0, 1, 1, 1. Because it's smaller than a byte, right? A byte would be 8 bits. But we're being more efficient here. We're exploiting the knowledge of the frequencies. Okay, so O would be the same, but with a 1 at the end. 1, 0. 1, 0, 1, 1, 0. S would be 0, 1, 0. T. I'm really impressed that they actually cover Huffman coding. This is like university level material, and I've seen students struggle with Huffman encoding at master's level, because I was a teaching assistant for these courses, and I had students struggling with these all the time. 1, 1, 1. Student was asked to describe how a Huffman tree could be created for the string in figure 2. Her response was, oh man, got to find 4 mistakes. Okay, I would count the number of times each character appears in the string and create a frequency table sorted alphabetically. Okay, I'm fine with that. For example, the letter S has the highest frequency in figure 2. Probably does, yeah. It has the joint highest, but that's not, she didn't make a mistake. Okay. Next, I would take the 2 characters with the largest frequencies and combine them into a new node. Okay, this is, I don't remember how you make a Huffman tree, so I don't remember, I can't. You choose the first split to make it as even as possible, don't you? So there's 20 on the left and 16 on the right. So you... can't remember how you design your tree. I would think you want as even a split as possible each time. And that does seem to be the case here. But how do you even do that? How do you split them as evenly as possible? That's a hard problem in itself. I don't think that's what... Got 20 and got 16, so we could have moved U over to the other side. Yeah, no, I don't think that's it. I don't remember. Okay, this is what she's saying. Largest frequencies and combine them into a new node. Oh, she's along the right lines, I think. Yeah, what I said about splitting is not what you do. Because that in itself is a hard problem to solve. So she said combine S and SP. So you don't start from the root, you start from the... Let's assume she's right. The new node would be added to the end of the frequency table. Agreed. The two characters with the lowest remaining frequencies. Ah, but she's ignoring the S and the SP. Ah, okay, that's one mistake. Okay. Okay, so one mistake. The two characters with the lowest remaining frequencies. Incorrect. The student has should be treating all combined Well, maybe she is doing that. I don't know. All combined nodes as new characters with the respective frequencies and counting those and counting those as well. Okay. But I don't think you combine the two. Oh, no, you don't combine the two most frequent. You combine the two most infrequent, don't you? And make them more frequent. I think that's what you do. So because they're so infrequent, you combine them together and that new node will have the added frequency of those two. And then you work from there with that. Yeah. I think that's... Good. At each step, student should take the two least frequent characters, not the most. Yeah, that's okay. Process is repeated until all the characters have been added to nodes and the tree created. No. You finish when the tree is connected. So you could start with adding B and I together. Your next step could be to add N and H together. You'd have two subtrees. You finish when the tree is connected. For example, we could get to 20. We could get here and here at these two subtrees without having the root node. But we don't finish there, even though we've added all characters. If what I said made any sense. Should finish when tree is fully connected with a root node and all characters added, not just when all characters characters have been added to nose, as the trees may be disconnected. All right, one more mistake. I'm wasting time here. Sorted alphabetically? Does it matter? Well, why would you sort it alphabetically? No, sort it by frequency. It doesn't actually matter if you're going to identify the highest anyway. But I think this is probably a wrong step if you're following the algorithm as standard. So freak table should be sorted by freak, not alphabetically. All right. But then again, that's fine. I am going to lose marks there. When the Hoffman tree in figure 1 is used, string in figure 2 can be represented using 130 bits. This 36 character string shown in figure 2 could also be encoded using ASCII. How many bits are saved when Huffman coding is used rather than ASCII to represent the string shown in figure 2? Okay. So in Huffman, we used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. Should I just, how much working do they want? I don't think much. Okay, ASCII. It will be 8 bits. 8 bits per car. So 8 times. Oh no! What am I? Hang on. String in figure 2 can be represented using. No, it's not the word most. Okay, they already told us it's stored using 130. Okay. Okay, fine. It's the longer string. Okay, ASCII 8 bits per character. So it's 8 times 36, including the spaces and everything. So that's 8 times 36 is 288. So saved equals 288, take away 130 equals 158. It's a lot. Okay. Define the term computer network. It's a network. A series of computers that can communicate and send data between computers, I guess, at the most rudimentary level. Communicate. 2 marks. Computer networks can be wired or wireless. Discuss the advantages and disadvantages of wired and wireless networks. 9 marks. What the f... What is this? I don't know this stuff. I should know this stuff, but I don't. Oh my god. Alright. I can't even think of 9 things to talk about. Advantages. Okay, let's just say advantage of wired. You would get a stronger signal that is generally distance independent and not obstructed by physical obstacles, like, I don't know, if you happen to be coding in a Faraday cage. Secure, more secure. Harder for attacker to spoof the router or whatever and pretend to be a legitimate user. Harder for attacker to intercept signal without physically connecting to the network. What else? Advantage of wireless. Less cost. No need to set up wires through the building and maintain the cables. Convenient to use with wireless devices. That's an obvious one. I basically said like 1, 2, 3, 4 to 5 points here. How am I supposed to get 9 points? Advantage of wireless. Less cost, no need to set up wires through the building and maintain cables. Convenient to use with wireless devices. Speed in theory is the same. It might be faster with wired, but that's mostly because of what's happening at the router. I don't know. You can't lose marks for saying this, can you? So let's just say it's faster. Faster speed, lower latency. I mean, is that really true? Is there really a significant difference? I don't know. I don't work with cables. I don't work with this practical stuff. I just code. Advantage of wireless. Less cost. No need to set up possibility and convenience to use the wireless devices. I mean, wired is generally easier to get authenticated may not require username login details. You may still require, but generally you don't, the way they set them up. To access is this the man in the middle attack? Let's just say that. Might get a mark for that. I don't know. Despite higher cost in setup, less admin maintenance is required. I don't know if that's even true. I'm just saying it. To maintain the network. I mean, I always have Wi-Fi problems, so okay, that's enough. That's not even 9 points, but 9 things I've said, but good enough. Right. State which layer of the TCP IP model. I don't remember any of this stuff. Four marks, so even if we pick randomly, we'll probably get a couple of marks. Right, application layer. That's HTTP, right? Okay, I don't know. I'm going with these. These feel like they might be half right. Hopefully get at least 2 marks. Okay, define the time cybersecurity. Is that even a technical term? Security related to digital devices and networks. Yeah. 2 marks? Come on. Involves I don't know, cryptographic protocols and I don't know. Define the term malware. Harmful software that is intended to I mean, malware, viruses, all these things, they kind of mean different things, but people tend to use them interchangeably. What exactly is malware? I would assume just anything that causes negative harm to harm the user's device. Well, this is computer science, so let's say computer, e.g. slow down processes. I wouldn't say steal data, because that seems more like virus than malware. Malware is kind of just, or maybe that would be considered malware, I don't know. Also, that tend to harm the user's computer, e.g. slow down processes. Show ads, show unwanted ads, record. Okay, I'm just gonna say stuff that I don't even think is defined to be malware. Record key presses and user activity. Let's go with that. Explain how each of the following cybersecurity threats could be used by a student to gain unauthorized access to a school network. So this is starting to become more like IT than computer science. Or at least, I mean, I did IT when I was in school, and it was more like this stuff. Computer science, I would have thought would be more the mathsy stuff, but I guess they've combined it with IT, because IT is becoming a bit outdated because everyone knows how to use computers nowadays, even when it comes to spreadsheets and stuff. So each of the following cybersecurity threats could be used by a student to gain unauthorized access to a school network. Okay. Weak and default passwords. A student knows a user's password. They can log in as the user and gain the user's full access rights to their machine or network. Users regular access rights to the machine or network. Okay. Misconfigured access rights. If access rights are misconfigured, I mean, it's self-explanatory, isn't it? Then the student can read files, connect to networks and devices that were not intended for them to use. I don't know. Removable media. Removable media? I don't know. What? Removable media could contain software or viruses that no, what do they mean? Gain unauthorized access, so we don't care about what they do to the network. Could contain credentials that would allow the student to gain unauthorized access. It always comes down to gaining unauthorized access, so gain unauthorized access, unpatched, outdated or unpatched, say outdated software may have exploits that could be used to gain unauthorized access. Should we say e.g., I don't know, SQL injection? They want us to describe some possible consequences. So students could delete, could display or delete important data in a database. It could also contain software or viruses that, when introduced to the network, cause harm. Let's just keep adding random things. Let's steal data. In both the above cases, student could access private data, e.g., students' grades, or even change grades. Let's see if that gets us a mark. Or view confidential data such as students' medical records. I've got 30 minutes left. Let's just carry on. Shade 1 lozenge to show which statement best describes the definition of the term social engineering. Manipulating people so they give up confidential information. Phishing is a form of social engineering. Describe 2 methods a school could use to protect its staff and students from phishing. Restrict staff and students' emails from receiving emails from outside or unrecognized sources. Sanitize all links, attachments, and images in emails. Scan and sanitize all links in emails. Educate the students and staff on how to spot phishing attempts. Maybe trial, I mean, my university used to do this. Maybe trial a fake phishing scam built by the IT staff and monitor how many staff and students click on the links. open a helpline that students and staff can forward suspicious emails to. Okay. A healthcare publication contains the following article. This item cannot be reproduced here due to third-party copyright restrictions. Explain 2 potential legal and or ethical impacts of using implanted microchips in healthcare. Oh, we can't be shown the article. This past paper doesn't have the article because of copyright. Well, what idiot put a copyrighted article in a question paper? Okay, we probably don't need it. So stupid. Okay, implanted microchips in healthcare. What? What is bad about implanted microchips in healthcare? Ethical. Security is a risk. Attackers could access data on or about the microchip to gain confidential data on the patient. I mean, what kind of microchips are they talking about? Are these isolated or are they connected to a network? Legal? Well, that depends on the... Legal. What is the legal impact of using implanted microchips? I mean, in theory, it's okay. It depends what they really mean. Attack. Legal. I mean, if it's not connected to a network, I don't think it's that there really are any concerns, to be honest. It's okay. It seems okay to me. I mean, if it's saves someone's life or something, then by all means do it. Are they just talking about microchips that access a network? I don't like this paper. Paper 1 was way more fun. This is the last question. I mean, there's health risks. You're sticking a foreign object in your body. Maybe that's a legal risk as well. Legal health care in healthcare provider is liable should the microchip defect or cause harm to the patient. I mean, It's never good to have a foreign body in your foreign object in your body. Two potential legal unearths. 4 marks here. E.g. if they use an MRI machine. Don't underestimate the patient's stupidity. Security is a risk. Attacker could access or kill them. I don't know if it's managing their heart or something, cause harm to them. In what's the game? Hacknet. One of the missions in Hacknet, you actually have to kill someone by hacking into their pacemaker and patching it to an older patch so that you're able to use an exploit of some sort to kill them. It's quite an interesting mission. I should replay that game actually. I bought the DLC for it, so it's worth a replay. That's the end of the paper. I do not feel happy about. Oops. Okay, I do not feel happy about this. We've got 20 minutes left. Let's go over these again. I think I probably got the mathsy ones right. Give 2 reasons why hexadecimal is often used instead of binary. Smaller length strings definitely is one. Makes better use of ASCII characters? That doesn't make any sense. What do I really mean though? Honestly, I think the only advantage of hexadecimal is the strings are smaller. Because everything else is equivalent. That's literally the difference between it and binary. It's shorter. So what other reason is there? I don't know. It all comes down to how many characters you type, surely. I mean, okay, why do we use hexadecimal instead of decimal? Because it's powers of 2. But that's not the question here. It's more convenient for computer sciencey stuff because everything in computer sciencey tends to be in powers of 2. Why do we use it instead of binary? Okay, don't worry about this question. Add together this. So yeah, 0, 1, 0, 1, 0, 1. Yep. 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 I know. Two reasons why data compression is often used: reduce space, reduce time. That's the 2 reasons. Oh, this one we didn't do. State the feature of data that allows it to be compressed effectively using RLE. I don't know what RLE is. Run length. Okay, I reckon you pick a length. Okay. This. I reckon you do something like you pick a key length, e.g. k equals 16. The data is divided into blocks of 16 characters. Then what? But how do you compress it? This doesn't solve anything. Run length encoding. Could a run be where you have the same character multiple times? No. I have no idea what run length encoding is. I'm sure I probably know it by a different name. But every time I try to think of how you would compress stuff, I just keep thinking of Huffman. Because Huffman is so great. Why would you use anything else? At this level, at least. I know more about cryptography, but not much about compression, actually. It's just something I take for granted because we have libraries that do all this for us. Don't know the answer to that. Control unit? I think it's control unit, not BIOS. Because they mentioned control unit later on, so I don't know. Go with that. Control unit, memory. They mentioned control unit and memory. There's probably that and shared. No, what's shared bus? No, we don't need shared bus. That's allows multiple devices or systems to use the same section of memory, but you don't need that strictly. Maybe it's BIOS then. Let's go with those three. Main memory is any form of hex memories. Main memory is your short-term storage or running programs and context switching. In particular, to permanently store data for when we switch off the machine. The Hoffman question. Okay, in the end, I feel like I got 4 points out there. Okay, I think that's right. And possibly a control hub 9 marks here. Strongest signal, distance independent, not obstructed by physical obstacles, more secure, harder for attacker harder for attacker to intercept signal, faster speed, lower latency, maybe use it easier to get authenticated. I mean, is this faster if you're not sitting far away? Isn't it? If you're well, that's more about quality than speed. Well, it would impact speed if you have to repeatedly get data, because the last batch of data was distorted or something. Noisy. Noise? Should I talk about noise? Noise can cause quality loss in signal. Don't know, just mention keywords, might get you marks. Noise from should I say noise from outside sources? Like phones, microwaves. Okay. You know what? Okay, we've got 10 minutes left. I don't even really want to look at these questions anymore. I feel like I just want to go straight to marking. What can I say about that? I don't know. They didn't give us the thing here. I feel like we're at a disadvantage. Should I just grade it? Alright, let's do it then. Okay. That was basically IT. That wasn't really computer science. Well, it was a bit, but... Not that I'm saying that's a bad thing. It's just different to what I'm used to in what I refer to as computer science. I mean, this would... Okay, a lot of this would actually come up in operating systems, which is usually a course in computer science. But even in operating systems, we don't really look at legal and ethical impacts and stuff. Well, maybe a bit, but not much. Okay, so... Okay. 148.94 8F. Nice. 10111110. Yep. Okay, let's see. Easier for humans to read than binary. Is it really? I think that still just comes back to smaller length strings. Is it actually easier to read? I don't know. I suppose it's easier to interpret the decimal value of that number in our heads because it's closer to looking like the decimal number. But at the end of the day, we just want to convert everything to decimal in our heads. Okay, anyway, quicker to type in. I said that. Well, easier to type, yeah, close enough. It reduces the risk of typing errors. But that's just because there's fewer characters, isn't it? Numbers are displayed in a more compact way. That's just another way of saying every one of these points is just basically a synonym for hexadecimal strings being shorter. Can I get 2 marks out of this? Well, I got 1 mark. Easier to type. Makes better use of ASCII characters. That what I was getting at there was probably okay, whatever. It's 1 mark. Clearly that second thing I wrote doesn't match anything they've said, but really they wanted you to just say smaller length strings, but say it in 2 different ways. That's what they were asking here. It's stupid, really. Okay. But that's GCSE. Let me just record how many marks I've lost. See, you gotta know what they're looking for. That's the key. That's what teachers teach you. That's what good teachers teach you. Alright, lost. 1 mark. 110, 110, 10. 110, 110, 10. Yeah. One 0 1 0 0 1 0 0 1 0. Yeah. 63, and then 40,000. But I did it correctly, and they've done it wrong. But are they taught at GCSE that there's 1,000 bytes in a kilobyte? Because there aren't. And even at school, I was taught that there are 1,024, not 1,000. I distinctly remember that. And I know that some operating systems, I don't know, Mac or something, they use 1,000. So when you're hovering over the size of a file or something, it might be Windows or Mac, I don't know. But that's not computer science. That's just making it easier for human beings to understand. But in computer science, the science, we always use 1,024. Nevertheless, whatever. I got it wrong because the mark scheme says I'm wrong. The point of this whole stream was an experiment, really, to see what I would have got if I were to sit with the paper right now, so apparently I lost a mark there. I mean, I knew that might be a possibility, but I didn't know what to do. Do I go for the 1,024, which is the correct answer, or do I go for the 1,000 and risk getting it wrong if they really did want you to use 1,024? You never know. Alright. So I got 1 mark for doing the correct process. Okay. The wave is converted to... The amplitude and height of the wave is measured. Yep, I said that. The sampling takes place at regular intervals. Yep, I said that. Samples are stored as binary values. Well, I said bits. That's referring to binary values, right? Because technically it doesn't need to be binary. You could store it, I don't know, trinary, decimal, whatever you want. No, but I think when I said bits, that's clear enough that I meant binary. That's what bits it is. So yeah, I think I got the 3 marks. One 320. Yeah, because here I used 1,000 just for convenience. Okay. More than one lozenge shade. Process of encoding information to try and use fewer bits. Yep. So I've only lost 2 marks so far. Okay, fine. Give 2 reasons why data compression is used. Space and time. What have they said? Space and time. That's the first point, basically. Okay, here we go. And I'm not going to get these marks. Data contains a lot of runs, repeating values. Oh, I said it. But then I thought, nah, that can't be right, can it? I mean, I should have written it down because that's better than what I wrote. Repeated appearance of certain sequences, not quite. Nope. I said it and then I was like, nah, that couldn't be right because it just seemed like really contrived data. But then again, there could be like, I don't know, you're doing science experiments and stuff. It could well be that you have data of that sort. So I should have gone with that. Yeah, I remember this now. Okay, so we've lost 5 marks so far. Okay, BIOS control unit memory. Damn it, I had it the first time. No, I didn't. Okay. Either way, I had only 2. So, what did I say? Shared bus. Yeah, okay, I see it now. Yeah, shared bus. I remember back to my electronics days. Shared bus is always there. Control unit of memory. Yeah, BIOS. You don't need a BIOS for it to be a von Neumann computer. Like, we're talking about the most rudimentary form of computer. So, cool. Stores data while a program is... Yeah, I said while running programs. Oh, hang on. Okay, I got 1 mark. I think I misunderstood the question here. I thought they were asking to compare RAM with, like, ROM or whatever. That wasn't really the question. They want you to say how the memory, like, literally is used, like how the addresses work and all that. They could have made the question a bit more explicit, but whatever. 1 mark, I guess. Yeah. Not happy so far. I've lost 8 marks. Okay, RAM and secondary storage. Cleared when the memory is off. Yep, I said that. Capacities. Faster, yeah. Security and access privileges. Security, yes. And an input and output preference. Yes. Good. 10111, 10110, 010, 111. Okay, this one I didn't fully understand. Yes, I got that first point. Should be sorted by frequency. Yes, I got that. Letter S does not have the highest frequency. E has the highest frequency. Oh, I didn't spot that. Damn it. The new node should not be added to the end of the frequency table. The new node should be inserted to the correct place. Okay. So what I said about the root, about the disconnected trees, that's not. I think she was sort of implying the correct usage, but she just wrote it very simply. I got 2 marks then. Well, it's better than no marks. I mean, I don't really understand that. $122. 36 characters times 7 bits. 7 bits? Oh, ASCII uses 7 bits, not 8 bits. Does it? I thought it uses 8. I never think of the binary value, I always think about the hexadecimal. Okay, fine. Damn. So I got 1 mark because yeah, I suppose that makes sense. I'm just so used to the number 8 appearing everywhere. Define the term computer network. Collection, a group of computers, yeah. Wait, how many marks? Connected, joined together, yeah, I said both those things. Well, references to allowing the sharing of resources if context is correct. Okay, I didn't really say they were joined together, but I did say they can communicate and share data, send data, so I think they've awarded you that at the bottom here. Okay, fine. Alright, this one. Oh man. What is this? Okay, have they... Okay, let's have a look at this. Advantages. Connection speeds are typically faster. I did say that, yeah. They typically have higher bandwidth. I didn't mention bandwidth. Typically have better security, fewer security risks. So I said those 2 things. I mean, how many points do you have to mention? So I said, I didn't mention bandwidth, but lower setup costs. Yep, I mentioned that. No wires, cables required. Yep. Easy to connect new devices. Yep, I did say that. Users not confined to a single location as they are within range. Convenient to use with wireless devices is what I said. I feel like that's the same sort of concept. Yeah. Yeah. Can connect to multiple devices without the need for extra hardware. Well, that comes under setup cost, doesn't it? Can connect to multiple devices without the need of extra hardware. So it can add to the network and take... Well, depends. I think that's just really another way of saying... Because you can set up the wires that you allow for other people to enter the network who aren't here, like empty desks and stuff. But then the setup... Okay. It's probably not the same as what I said. And some of these are just the opposite of... I don't know how many marks to award myself here. Thorough discussion of advantages and disadvantages of both wired and wireless networks. Security of both types of network are compared in detail. The response is well structured and coherent. Responses at the lower end of the level will contain mostly discussions, but may also include some thorough explanations of the advantages and disadvantages of both wired and wireless networks. The security of at least one type of network is explained in detail. The responses was, I didn't know they were expecting us to write an essay. The security of at least one type of network is explained. What do they mean by that? Look, I said something about harder for the attacker to spoof the route and pretend to be a legitimate user. Man in the middle attack, harder for attack. I think that's explaining the security of one system. So I reckon I would get around 6 to 7 maybe, because okay, you didn't have to have all of these, but you had to hit some of them, and I did. But I don't think I didn't contain thorough discussions. I just wrote bullet points. Security of both types of network are compared in detail. Did I really do that? Not really. Security of at least one type of network is explained. I did do that. I didn't explain both. I explained one because that was the one with the man in the middle attack. So I reckon 6. Because I don't see any argument for why I would get fewer than 6, because I did hit these goals. The response makes sense when read as a whole, and logical trail of thought is apparent. Yeah, I think so. So, based on the fact that I didn't explain both, well, even... I reckon 6. Let's go with 6. This one's really... I don't know how you're supposed to mark these. This is the one which they probably attend courses teaching them how to grade these. So I don't know if that's even generous or harsh. I have no idea. I'm going to give myself 6 for that. That means I lost 3 marks. So we've lost 14 marks so far. Oh god, I got this all wrong. I got 2. I don't know what these things are. I know that I should know what these things are. Oh. Both of these are application layer. I didn't know they were going to give us 2 that map to the same one. Okay, fine. It's not looking good. I don't think I'm going to get the top grade anymore. Maybe the second top grade. 8. 8 out of 9. Define the term cybersecurity. Security related to digital devices and networks. I didn't. Protect networks, computers, programs, data. Digital devices and networks. I feel like I've hit this first bullet point, just worded in a very different way, but I didn't really elaborate on what I meant by security, so I think it's 1 mark. It could even be 0, but I think 1, because I have mentioned networks. It's just in very different words. I think 1 mark. define the term malware. I don't even know what the term malware is. It's just used differently by lots of program code with malicious intent. Yeah, that's what I said. Response to this is a thorough explanation of how all of the threats could be exploited by a student. This was a clear reference to a school network. I did do that. More than one consequence has been described. I reckon I should get full marks here. If I've hit some of these. Students could use brute force, weak admin passwords could... Oh, they wanted to know what flaws in password. I didn't know what they were asking for. They're asking how a student could get a password. They didn't really ask that in the question. They just said how each of these threats. Nevertheless, I've... Alright, let's look at misconfigured access rights. Areas they're not supposed to. Reconfigure network, create new user accounts to give themselves admin access. Okay, I said read files, connect to networks and devices. These are all valid, I think. Removable media could say malware. Yeah, I mentioned that. Could be used to steal data, I said that. Take control of certain network processes. I didn't mention that, but yeah, I don't think you need to mention all these things. Unpatched or outdated software could allow students to exploit known weakness flaw. Yep. Once a student could install malware. So I mentioned SQL injection. So I've mentioned an example. Again, I have no idea how to grade this. I think I didn't explain the passwords thing fully. But I explained the consequences, but not how they actually get the password. Because I didn't know that's what they wanted us to say. The other stuff, I feel like I hit some of these points for each one. So that's... I think I've met level 4, mostly. So maybe I lose 1 mark for not mentioning how they gain passwords. More than one consequence has been described. Yeah, I have mentioned more than one consequence. So I reckon either 6 or 7. But I don't see any reason to go to take 2 marks off. I'm gonna go with 7. I don't like grading papers like these. In fact, now that I've seen what these essay questions are like, I would have second thoughts about even doing this paper as part of the GCSE challenge and just stick to paper 1, but started it already, so we'll continue. Part of manipulating people so they give up confidential information. Yep. Train staff students to be cautious of emails. Yeah. I think I got those 2 marks for the second one. Okay, restricts. Prevents students from being able to download anything from internet. Copy web addresses from... Example response. I reckon I got marks there. Like I'm looking at that, I think I wrote sensible things and explained them. So... Oh, this one. Okay, consent. I didn't mention it. If a hacker gains access... Oh, yes, I did that. So 2 marks there. I mean, what I wrote in the second point is a fair point, isn't it? I mean, you can't use an MRI machine if you have a microchip and someone might go and use one without realizing, like, just, I don't know, they had a moment of stupidity. Healthcare it causes risks to them. And to be fair, I didn't have the article that I'm supposed to read, so I probably, if I had access to the article, I would have got 4 marks for sure. So I think what I've written here is worth 4 marks. So let's go with 4 marks. That's it. So overall, I got 62. And some leeway. I've been maybe a little bit generous. I feel like maybe there could have been a couple of marks that the marker wouldn't have given me, especially in those essay questions. But let's evaluate. So in the first paper, I got 76 out of 80. The second paper, I got 62. So altogether, I got 138 out of 160. So the question is, okay, first let's look up the grade boundary. I think that's top grade, but let's look, more importantly, let's look how far above the threshold I was. So this was 2020. Okay, AQA GCSE Computer Science Grade Boundaries 2020. 2020, here we are. Computer Science. Okay, maximum mark 160. Grade boundaries 135 for the top grade. I got 138, so I could have lost 3 more marks and I still would have got the top grades, so that reassures me a little bit. Let's say I were to be a bit harsher on that one, give myself 6 or even 5, and that one, give myself 5, then I would still get the top grade. So I'm okay with that. I'm trying not to be overly generous. I'm trying to be realistic for what I think I would actually get, but it's not easy to be impartial. So I can safely say I think I got top grade, which is 9. That's computer science. Only just. So let me just enter that into the spreadsheet. So nine, predicted 9. I was predicting between 8 or 9. I couldn't decide what to go with, but I went with 9 because I feel like if computer science was my postgraduate degree, then I should be aiming for 9. So I got it, but just, that was a close call. I didn't realize how much IT stuff I would need to do in this. Let me just write down. So it's 138 out of 160. Okay. Cool. So I guess what will I want to do next? Statistics, I think. Because statistics should be my next strongest subject. And it's another course I never had the opportunity to do when I was a kid. So it's another one I'll be very interested to see what it is involved. I should get 9 in that. I mean, I might even be stronger in statistics than I was in standard maths. Simply because in standard maths at GCSE, I think they throw in a lot of topics that I just don't remember, like circle theorems and stuff. But statistics, I reckon, should be closer to real statistics that you do in the real world, which I have some familiarity with, so I would aim for 9. Okay. So we passed computer science. I mean, you passed by getting a 4 or a 5 at least, I think. So that means we are on our way to actually get a job and not wind up in McDonald's yet. Let's see what we get with our other GCSEs. Yeah, so maybe in a few days' time, I will start with statistics. All right, cool. See you next time.